بسم الله الرحمن الرحيم. The last lecture we get to the properties of the cross product. We spoke about the cross product A cross B, and we gave some examples, and also we stated the properties for the cross product. These properties were the first one was A cross B equal to 0 if A equal to 0 or B equal to 0. This is not only an or if and only if statement, because we have some cases where A cross B equal to 0 for non-zero vectors. That will be called when they are parallel. But this is just one direction statement, A cross B equal to 0 if A equal to 0 or B equal to 0. Second one, A cross B equal to minus B cross A. If we reverse the order, the direction of the vector will be also reversed. It is associated also A cross B plus C equal to A plus or A cross B plus A cross C. A cross A will give me 0. A dot A cross B equal to 0 and B dot A cross B equal to 0. For the fifth and sixth property, we said that A cross B is orthogonal to both vectors A and B. This is the meaning of the fifth and sixth one. A dot A cross B equal to 0 means A is orthogonal to A and B. B dot A cross B means that also the cross product A cross B is orthogonal to the vector B. For the direction of the A cross B, we use what's called the right-hand rule. And the rule says that if the fingers of the right hand point along the vector A and then curve toward the vector B, the thumb will give the direction of A cross B. If the fingers of the right-hand side along A and then curve toward the vector B, we will see that A cross B will be up. If it isn't reverse, it will be down. Now, just to check the fifth and sixth property, let's take this example. Find a vector that is perpendicular to both A and B, given that A equal to 2i plus 7j minus 4k and B equal to I plus j minus 4k. So we need to find a vector that is perpendicular to both A and B. It means we need to find the cross product for the two vectors A and B. So we need to find A cross B. Now the vector A cross B is equal to, using the determinant form, we have I, j, and k. A1 is 2, A2 is 7, A3 is minus 4, B1 is 1, B2 is 1, and B3 is minus 4. Now this is equal to I minus j plus k. For the first one, for I, cross the first column, first row. I will have 7 times minus 4 is minus 28. Minus 4. 7 times minus 4 minus 1 times minus 4. This will give me the components for the first one. For j, we will cross the second column. 2 times minus 4 is minus 8. Minus 1 times minus 4 is minus 4. For k, we cross the third one. 2 times 1 is 2 minus 7. So the cross product will be minus 24i plus 4j minus 5k. So this is A cross B. So we claim that this vector is perpendicular to both A and B. Let's check. So let's apply the dot product to check. So I need to find A dot A cross B and B dot A cross B. So the vector A is given by 2, 7, minus 4. Dot A cross B is minus 24, 4, and minus 5. By the dot product, we multiply the first one with the first one. So 2 with minus 4 equal to minus 28. Then 7 plus or times 4 is, this is minus 48, not 28. 7 times 4 is plus 28. Minus 4 minus 5 is plus 20, which is equal to 0. So A is orthogonal to A cross B. We got 0. Now let's check the second one. B dot cross B. B is given by, the vector is 1, 1, and minus 4. 1, 1, minus 4. Dot A cross B, which is minus 24, 4, and minus 5. We will have 1 times minus 24 is minus 24 plus 4 plus 20, which is equal to 0. So yes, A cross B is orthogonal to both A and B. So the idea of A equals B just to find, and that one will be perpendicular to both of them, A and B. Now, let's move to the next point, which is the magnitude of the cross product. Cross product. Say that for a non-zero vector, vectors A and B, if theta is the angle between A and B, and B, or theta is less than pi, then the magnitude of the cross product is equal to the magnitude of A multiplied by magnitude of B multiplied by sine theta. This is the magnitude of the cross product A cross B, or the magnitude of A cross B equal to the magnitude of A times magnitude of B multiplied by sine theta. Now, if theta equal to 0 or 180, the cross product will be 0. In that case, we say that the two vectors will be parallel. This one, we take parallel vectors. A and B. Are parallel. F and only F. A cross B equal to 0. Equal to 0 for A is not equal to 0 and B not equal to 0 for non-zero vectors. If their cross product A cross B equal to 0, then they are parallel. A cross B equal to 0 if and only if they are parallel. Let's have one example for this one. Determine whether the given vectors are parallel or not. Number one, let's say the first one, A is given by 2, 4, minus 6. B equal to 2, 3, and let's say 5. I need to check, are these parallel or not? So let's find A cross B. If it is equal to 0, then they are parallel. If the cross product is not equal to 0, then they are not parallel. So for the cross product A cross B, which is equal to I, J, K. A1 is 2, 4, minus 6, 2, 3, and 5, which is equal to, let's take this one. I have 20 plus 18, I, 4 times 5 is 20, minus 18 is 38I. Now, cross the second column. 2 times 5 is 10, plus 12 is 22J. Third one, 2 times 3 is 6, minus 8 is minus 2. So this is the second one, it should be minus there. Now third one, 6 minus 8 is minus 2K. and this is not equal to 0. So these are not parallel. Or just we can check that the first component. If we got the first one is not equal to 0, it means that this is not a 0 vector. From the first component, if it is not 0, so that's enough. But if we just find all the component of the vector A cross B, we see that this is not a 0 vector. Second one, say 2 equal to, or the A equal to 1 minus 5 and 2. B equal to 3 minus 15 and 6. So A cross B in this case will be okay, and it is 1 minus 5 and 2, 3 minus 15 and 6 is equal to, for I, cross the first one, minus 5 times 6 is minus 30, minus, okay, it will be minus 30 minus 30 I, minus. Now cross the second one, it will be 6 minus j plus. Cross the third one, 1 times minus 15 minus 15. Okay, and this will be 0i plus 0j plus 0k, or it is just 0 vector. So we can see that the cross product for this one is equal to 0, which means that A and B are parallel. Then yes, they are parallel. So if A cross B equal to 0, then they are parallel. If A dot B equal to 0, or I'm sorry, if A equal to C, B, or B equal to some scalar C multiplied by A, then they are parallel. So to check the parallel vector, we can use either cross product, or without that we have a common factor of the component. If we can write B as scalar multiplication of A, then they are parallel. Take now example. Find the angle between the vector A, say 2, minus 1 and 3, B, minus 1, 4 and 5. I need to find the angle between these two vectors A and B. We know that the magnitude of A cross B equal magnitude of A multiplied by magnitude of B multiplied by sine theta. So sine theta equal to magnitude of A cross B. divided by magnitude of A times magnitude of B. Means that I have to find A cross B first. Then we need to find the magnitude of the three vectors A cross B and the vectors A and B. So let's find A cross B first. I have I, J, and K. 2, -1, and 3, and we have -1, 4, and 5. This will give me, cross the first one, I have -5, -12 is -17. Next, cross the second one. Don't forget we have minus there first. 2 times 5 is 10. 10 plus 3 is 13. So 13 J. No, the 4K, cross the third one. 2 times 4 is 8. Minus 1 is 7K. So this is A cross B. So the magnitude for A cross B equal to 89 plus 169 plus 49. Take the square of the component. 17 square will be 289. 13 square is 169 plus 7 square is 49. This will give me 289 plus 169 plus 49. Square root of 507. Now the magnitude of A is equal to square root of 4 plus 1 plus 9, that is equal to square root of 14. Magnitude of B is equal to square root of 1 plus 16 plus 25, equal to square root of 42. So this means that sine theta will be square root of 507, which is the magnitude of the A cross B, divided by magnitude of A equal to 40 multiplied by magnitude of 42. From this one, we can find the angle, which is theta equal to sine inverse of all of these. That will be square root of 507 divided by square root of 14 multiplied by square root of 42. And then using the calculator to find theta, or the angle between the two vectors A and B. So this is the idea. Find A cross B, then find the magnitude of the vectors A cross B and the vector A and vector B. Then apply the formula sine theta equal to magnitude of the cross product divided by the product of the two magnitudes of the vectors A and B. Then use the sine inverse to find the angle between the two vectors.